Okay, so here we are looking at different fractions of crude oil, okay, this investigation. We're going to look at a variety of different properties of these fractions. So the fractions we're going to look at are petrol, diesel and fuel oil. And if you remember from the previous lesson, these, in terms of the fraction of distillation column, petrol is a shorter chain hydrocarbon fraction, so it condenses higher up in the fractioning column, diesel a little bit lower down, and fuel oil towards the bottom, okay? So remember, these are fractions. The fact that we're talking about fractions, that is relevant. We're not talking about in particular molecules, we're talking about a range of molecules, almost like a small mixture of molecules, but they're all got very similar number of carbons in their chain, which means they have very, very similar properties, okay? So, you know, in petrol, we have a variety of different hydrocarbons, but they all have approximately, it's about 5 to 10 carbons. Okay, so a variety of molecules, all alkanes, ranging from about 5 carbons in their chain to 10 carbons in their chain. In diesel, we're looking anywhere between sort of 12 and 20 carbons in their chain. And fuel oil, we're looking at anywhere between 30 and 50 carbons in their chain. Okay, so they're getting much larger. Okay, so more carbons in their chain, larger molecules. These are all alkanes. Okay, so they're all saturated hydrocarbons, so single bonds between all the carbons and hydrogens. No other atoms in there other than carbon and hydrogen. The only difference is the length of these chains. So the only difference really between the fraction of petrol and the fraction of diesel and the fraction of fuel oil is length of hydrocarbon chain, size of the molecules. And we'll be able to see the effect that has on their appearance, on the viscosity of the liquid, which is basically how easily it pours. So if something is viscous, it's very, very difficult to pour. Think about things like honey, that's very viscous, whereas water is not very viscous, it's very easy to pour. How easy it is to ignite, the smokiness of the flame, and then we're going to rank them from most to least flammable. And that's relevant because if you think about the main uses of these hydrocarbons, it is as fuels. Okay, so the fact that they ignite easily, or they burn with a clean flame, or that they're quite flammable, that's actually really useful if you're going to use it as a fuel. If it gives you a really smoky flame, then that's not very good. If it's very difficult to ignite, that's not very good. So we're going to start with the appearance. So first of all, we've got petrol here. Okay, so you can see that is a clear liquid. Let's place that there. So it's a colourless liquid. We have diesel, which we have here, which has got a very slight sort of yellowy tinge to it. So we're going to say pale yellow liquid. And then we have fuel oil, okay, which is a much sort of darker orangey brown. Right, in terms of their viscosity, if we look at petrol, it's pouring very, very easily, isn't it? It's moving around in there much like water. Okay, so it's not very viscous. We look at the diesel. Okay, now it's difficult to see on the camera, but you can probably see it's sort of sticking to the edges. Okay, if you can look at it sort of sticking to the edges of the test tube. If I tip it back, it does all collect back at the bottom, but it's a bit slower. It pours slower, so it's quite viscous. So I'd say a little bit viscous. And then if we look at the fuel oil, you can see already it's pouring really slowly. It's thick, it's like honey almost. Okay, and you can see it's still sticking to the sides. It's very, very viscous. So we're going to look at their flammability. So what I have here is a crucible lid, okay, with some wool. And I'm just going to pour some of the petrol. onto the wool, and we're going to see how easily that ignites. So just get my splint. And we should see, yeah, that was incredibly easy to ignite. Okay, so very easy to ignite. And we can look at the flame. Okay, we're getting very little smoke being given off. There is a little bit, but it's quite a clean flame. Okay, so ease of ignition was very, very easy. Smokiness of the flame, it's a very clean flame. So let's have a look now at the diesel. Do the same thing. I'm going to pour the diesel oil onto the wool. Just tip it up that way, just to get it to soak in. Light the splint. So you'll notice this one is not catching light as easily. It's going to need a little bit of encouragement. Okay, there we go. So it has begrudgingly ignited. Okay, but you can see it's nowhere near as flammable as the petrol. Okay, so ease of ignition was not very easy. Let's move the camera away from that a little bit. So it wasn't it did ignite though, but it wasn't as easy. And when you think about it, anybody who owns a petrol car, okay, you turn the ignition and that petrol ignites in the engine. But in a diesel car, you have to first compress and then heat the diesel before it will ignite. Okay, and that's because it's so much less flammable. Okay, and then let's have a look at the fuel oil. Let's pour that on. And let's light our splint. Right. Looks like it's trying to go. Bear with it. Oh, okay, there we go. The splint doesn't want to go out. Right, so it has eventually lit. So ease of ignition, it's difficult to ignite. And I don't know if you can see, but it's a really smoky flame. Ah, there we go. You can sort of see that black smoke coming off. Okay. Now, because it's such a long hydrocarbon, we're getting a lot of incomplete combustion. It's difficult to get enough oxygen to break it down. So what we're getting is this is soot, this is carbon that's being given off. Okay, so we've got a really smoky flame. Okay, the diesel actually had a reasonably clean flame, so we're going to keep that as clean. And then we had a really smoky flame for the fuel oil. But once it's gotten going, and it wasn't very easy to ignite, but now it's going, and you compare that to the diesel, it's actually going quite a bit faster. So once it's burning, you get quite a lot of energy, but it's very difficult to ignite, and again, you get this really, really dirty flame. So most and least flammable. Well, I'm sure we can agree that the petrol was the most flammable. Sorry, it just occurred to me you can't see that. There we go. So we've got the most flammable was the petrol. So the petrol it's not very viscous. It was very easy to ignite, had a very nice clean flame, and it was definitely the most flammable. And the fuel oil was the least flammable. It was much harder to ignite that. Okay, and it was very, very viscous, very difficult to ignite, got a very, very smoky flame. So, looking at this then, so if I move that out of the way, we should see that as we're going across, we're getting more carbons in the chain, the molecules are getting larger, and what we're seeing is that they get more difficult to ignite, they get more viscous, okay, and they get less flammable. So we can begin to put some of the things that we know together. So short chain hydrocarbons, thinking back to fractional distillation, we know that short chain hydrocarbons have low boiling points. We know that long chain hydrocarbons have high boiling points. And that is simply because the bigger the molecule, the stronger the intermolecular forces. So more energy is going to need to break them, so their boiling points would be higher. So we've got low boiling points for short chains, high boiling points for long chains. We saw their viscosity. Okay, short chains have a low viscosity. Okay, which just means they're easy to pour. Our long chains have a high viscosity. They are difficult to pour. We saw that the short chains were very flammable. And the long chains were not very flammable. And the last thing, the only thing we need to talk about that we haven't looked at already, is something called their volatility. Okay, so something that's volatile turns into a gas really easily. Okay, so when we're talking about a volatile substance, we're talking about something that becomes a gas easily. So a good example would be alcohol and water. If you wash your hands with water, you need to dry them, because rubbing your hands together isn't enough to evaporate the water. But if you were using an alcohol gel or an alcohol rub, just the friction and the heat generated from your hands is enough to evaporate that ethanol. So that's the difference in volatility. The ethanol is more volatile because it more easily becomes a gas. So again, our short chain hydrocarbons are volatile. Okay, they easily become a gas, and our long chain hydrocarbons are not very volatile. Okay, they do not easily become a gas. So what I want you to do now, you've got some exam questions. So here we have a diagram showing fractional distillation of petrol from crude oil. Okay, this is a very common 6-marker or 4-mark question that comes up, so make sure you go back to your flow map, make sure you're talking about all the correct key terminology. Okay, and there's the space there to answer it. And then after that you've got some simple progress checks. They're all multiple choice, so this should be nice and easy. So again, I will put answers on the channel at a later date. So for now, just complete it and just keep working through the lessons, and then I will come back at a certain point and say, right, here's the answers to all the questions I've asked you to do, so you can go back and self-assess. But just to reiterate, just make sure that you are checking Show My Homework regularly, and that you are checking in on all the different tasks, okay? Don't just assume it's going to be on the YouTube channel. Most of it will, but not all of it. You will need to check in on the individual Show My Homeworks so that you don't miss any instructions or any resources.